Alright, we're back for tutorial number 4 on XPL Pro. This time we'll be discussing how to work with datarefs that have arrays. If we go to the Xplane website that has the dataref search tool, you can see that some datarefs are array types. I can see on this one, this is the fuel pumps on for each engine. There could potentially be 16 engines, and there are 16 array elements that we could look at to process. Engine fires. Some of them are arrays of floats. Some of them are arrays of other data types. So if you haven't updated recently, go ahead and do that on my Patreon page or on the Discord page. I have created examples for you. There I am at the very bottom. In this case, I have XPL Pro arrays. I debated a bit about using my wrapping libraries, but I think I'm going to go ahead and mostly do that just because they make things so nice and easy. Once again, I'm using my standard button box prototype here. It's wired like this. This is what the wiring diagram looks like, if that's helpful to you. I've also provided these photos, and also this wiring diagram are within the example library, so you can reference them there as well. Alright, so I've defined pins here. Analog 0 and analog 1 are hooked to sliding potentiometers that are going to control throttle 1 and throttle 2, which are array elements. Pins 49 and 51 are connected to switches that will control generator 1 and generator 2. I'm also going to assign a dataref that we can read the current RPM as an example. Let's go down here in the register portion here. This line is asking for the dataref sim cockpit 2 for throttle ratio. Throttle ratio is a array type dataref. All we have here is a handle to it that we're going to use later. Here we are assigning a pin to match a specific element on the dataref. In this case, we want throttle 1 to be hooked to array element 0. We're going to ask for a precision level of 10. In the case of the mega boards, the analog pins, we get a value between 0 and 1024. This just tells it to divide that by 10 so that we can reduce the amount of data flow that's going to the plugin. If you want 1 on there, that's fine as well. Right here we're scaling. We're telling the plugin how to scale this data, and the math is done on the plugin. This saves the Arduino some processing time. So we're telling it that we're sending it a value between 0 and 1024, and that it should convert it to a value between 0 and 1, which is what that dataref element is expecting as a float value between 0 and 1. So this is all handled by the plugin. We're just telling it how we want that done. So we don't have to do floating point math on our Arduino. This is the same thing, but it's element 1, which is going to be the right engine. If you had 4 engines, it would be elements 2 and 3 for the additional engines. Now let's connect switches to those pins. I've got generator 1 and I'm generator 2. We want these switches to do a dataref write. I've also, for example purposes, I have also added XPL switches dataref write invert. So if your switch is acting backwards, you can use this and it'll switch it around for you. We're asking for access to generator on, and this at the end here is the element that we wish to use. So in this case, I've got element 0, element 1, which relate to engines 1 and 2 generators. Engine speed RPM is yet another float. This is a floating point array. And then we're asking for individual updates to that handle. This is how often we want to receive new data at a minimum. This is what precision we want. In the case of engine RPM, it comes in a highly precise floating point number, but we're not really interested in if it's 1023.65 RPM. So we're gonna, what this does, it'll only give us changes in excess of 20 RPM. And the purpose of that is just to reduce the data flow between the plugin and the Arduino. And of course, here's the element that we wish. So when the plugin has a different number for us, it will send it every, in this case, half second, and only if the change is more than 20 RPM. And we're asking for those two elements. We go up here. This is where the data will get processed. So if our handle is dref RPM and the element is 0 or 1, we can do whatever we want to do here. You can print it on an LCD or drive a servo, all kinds of fun stuff like that. Alright, let's give this a try. I have an Arduino Mega hooked up. Let's go ahead and send this to it. Looks good, no problems. I'm going to launch Xplane. Okay, we're up and running on Xplane. So I have my two linear potentiometers right here. It's wired in as the picture showed. They should control the individual throttles nice and smooth. I have these buttons connected to the generators. So one of them is inverted, so when I press this button, it turns it on. When I let go of it, turns it off. This should probably just be one of these switches. And then the other one, when I press it, it turns it off, and then when I release it, it turns it on. Thank you for watching. Make sure you subscribe to get continued updates on what we're doing with this project. You can download it on our Patreon page or also join us on Discord. The links are in the description box, as well as the components that we use within the video. See you next time. Thanks for watching.